Good day! With this video lesson, we're going to solve random math problem from the topic point of inflection under your differential calculus. Our problem: find point of inflection of f of x is equal to x cubed minus 3x squared minus x plus 7.
So in this problem, there is a given cubic function and we're asked to find the point of inflection of the given function. So first thing to do is to rewrite this function by simply using your letter y to represent your function. So we can rewrite this function as your y is equal to x cubed minus 3x squared minus x plus 7. Next thing to do is to find the first derivative of this y. So that will be y prime is equal to, what will be the derivative of x cubed? So we copy your exponent, so that will be 3. And we copy your variable. Then we subtract 1 to your exponent, so that will be 2. Minus, so what will be your exponent in your second term? So that will be equal to 2 multiplied by your numerical coefficient under your x variable. So that will be 3 multiplied by 2. So that will be 6. We copy your variable x. Then we subtract 1 to your exponent. So that will be equal to 1. So we don't need to put your exponent there. So because an exponent of 1 does not affect your value. Minus the derivative of x. So the derivative of x, so we subtract, there is a 1 here as your exponent. If we subtract 1 to your 1, so that will be equal to 0. So x raised to 0, so that will be equal to 1. Plus the derivative of your 7. So 7 is a constant. So the derivative of a constant is equal to 0. Next thing to do for us to find the value or to find the point of inflection of this function, we need to go with your second derivative. So now, what will be the derivative of 3x squared? So we multiply this exponent to your numerical coefficient. That will be 3 multiplied by 2. So that will be equal to 6. We copy your variable. Then we subtract 1 to your exponent. So that will be 6x. So minus the derivative of your 6x. So there's an exponent 1 here. So we copy. Then we multiply to your 6. So that will be equal to 6. Then we subtract 1 to your exponent. So that will be 1 minus 1. So x raised to 0 is equal to 1 multiplied by your numerical coefficient 6. So that will be equal to 6. So the derivative of 1 now, or the derivative of a constant, is equal to 0. So we don't need to put 0 plus or minus 0 here. So your second derivative, we assume that this one is equal to 0. Or we can say that your 6x minus 6 is equal to 0. So if we transfer this negative 6 to another side of your equation, so from negative to positive value, so that will be equal to 6x is equal to positive 6. So for us to get the value of your x, so we simply divide the entire equation by 6. So your 6 here will be cancelled out. Therefore, your x now is equal to 6 over 6, so that will be equal to 1. So now, there is a computed value for your x. What will be the value of your y? So from your original function here, we just simply substitute the given values of your x, or your computed value of your x. So your y now is equal to 1 cubed minus 3 1 square minus 1 plus your 7. So let's try to simplify. So your y is equal to 1 minus 1 multiplied by 1. It's 1 multiplied by negative 3. So it's negative 3 minus 1 plus 7. So there's a positive and negative 1 there. So it will be cancelled out. So your y now is equal to negative 3 plus 7. So we copy the sign of the higher value of the two numbers. So we copy the positive sign because 7 is greater than 3. So negative 3 plus 7 is equal to positive 4. Now, if x is 1, then your y is equal to 4. So meaning to say the point of inflection for this one, or the coordinates of the point of inflection for this given function or the cubic function here will be equal to 1 and 4. Now, let's try to recall for us to get the point of inflection of a given function. We need to get first your first derivative of the given function. Then let's go now to your second derivative. Then we assume that your second derivative will be equal to 0. Then for us to find the value of a given variable on that second derivative, then move forward with the substitution of the computed value to the original function for us to get the second coordinate. So with this given function, our final answer for the point of inflection will be equal to 1 and 4, both positive.